In this lesson, we're going to take a look at verifying inverse functions. So the first thing I need to do is tell you what an inverse function is. Inverse functions are simply two functions that undo each other. They cancel each other out. For example, here's f of x equals x plus 3 and g of x equals x minus 3. These two functions simply undo each other. And you can tell that if we compose them. So let's do that and see what happens. We're going to try it for f compose g of 7. So if I compose f compose g of 7, then what I'm really doing is f of g of 7. You remember from the composing lesson. And the first thing I have to do is figure out what g of 7 is. We'll go up here to the g function and plug in 7. So 7 minus 3 is 4. So that means that f of g of 7 is really just f of 4. Now I go to the f function and plug in 4. 4 plus 3 is 7. So you see that 7 goes in and 7 comes out. And that means that inverse functions undo each other. It shows you that inverses just undo each other. Alright, since inverses undo each other, when you compose two inverses, whatever goes in is what comes out. So if f and g are inverses, then f compose g of x will equal x, because what goes in is what comes out. That means that we can now tell if two functions are inverses by composing them. If f compose g of x equals x, and g compose f of x equals x, then f and g are inverses. Now it has to work both ways. You have to do f compose g and g compose f. It's not enough just to do one or the other. If you're going to say that they're inverses, you have to do both. Okay, for our first example, let's determine whether f of x and g of x are inverses. And for f, we'll have 3x plus 2. And for g, we'll have x minus 2 over 3. So the way to tell if they're inverses is to compose them. F compose g means f of g of x. So I'm going to replace g of x with what g of x really equals, which is x minus 2 over 3. And now I'm going to take the x minus 2 over 3 and put it in the f function. F is 3 times x plus 2. So I'm plugging in the pink stuff here. So 3 times the pink stuff plus 2 is what I get. And I have to simplify it. So the 3's cancel. We're left with x minus 2 plus 2, which simplifies to just x. And in order to make sure that they're really inverses, we have to do it the other way as well. So here's g compose f. That means g of f of x. Now I replace f of x with what f of x really equals, which is 3x plus 2. So 3x plus 2 minus 2 all over 3, because what I did was I plugged the pink stuff here in place of x. So the pink stuff minus 2 over 3 simplifies to simply 3x over 3 equals x. That's what we wanted. So since it equals x composing this way and this way, we can say that f and g are in fact inverses. Okay, here's another example. Determine whether f of x and g of x are inverses. So this time f of x equals 5x plus 9 and g of x equals x plus 5 over 9. So f compose g is going to be f of g of x, and g of x is here, this rational expression, so I replace the purple g with what g of x really equals. And then I take the purple stuff and plug it into the f function. So instead of 5x plus 9, I'm going to get 5 times the purple stuff plus 9. And I think after I distribute the 5, you can probably tell that this is no way going to simplify and give us x. If all I had to do on a test was answer the question, are f and g inverses, I would stop right here because you can clearly see that this is not going to make x. However, in my math lab, when they ask you this question, they're going to ask you to go ahead and give them the simplified version of f composed g, and it involves common denominators. So I just wanted to show you an example. And it doesn't hurt us to practice our composing and our common denominators anyway. So here we go. All I need to do is get this whole number a denominator of 9, just like this expression here. So if I multiply it by 9 over 9, then this expression here will become 81 over 9. And since they have common denominators, we make them into the same fraction, combine the 25 and the 81, and we get 5x plus 106 equals 9, because 25 plus 81 is 106. Or I said equals 9, but I think 5x plus 106 over 9 is what we want. Okay, so from there, we can tell that f and g are definitely not inverses. And there's an easier way. We can think of a function as a series of operations on x. And an inverse function then will undo the steps that the first function did in the reverse order. An everyday example of a function might be, imagine wrapping a gift. So we'll call gift wrapping a function, and the steps are, you take a gift, and the first thing you do is put it in a box. And the next thing you do is cover the box with paper. And the next thing you do is tie a ribbon over the paper. So the inverse of that is when you give it to somebody, they undo all the steps that you did. The first thing they have to do is untie the ribbon. So that was the last thing you did, but it's the first thing that they undo. And the next thing they do is remove the paper, and then the last thing they do is take the gift out of the box. So they undo all the steps, but in backwards order from what you did. So I'm going to show you an example of that method. We're going to verify that these two functions are inverses or not. F of x is 3x plus 7. And g of x is x minus 7 over 3. So if I think about f as performing a series of steps on x, and I think about order of operations, if you plug a number in for x here, the first thing you have to do is times 3. So I put times 3 in my list of steps. And after you multiply by 3, the next thing you would do is add 7. So then I'm going to put plus 7 in my list. And those are the only two things that are happening to x in this function. So when we think about f inverse, which by the way, f inverse is written like this. Instead of writing out the word inverse, we use this little -1. It looks like an exponent, but it's not. And when you see this, you just read f inverse. And so the list for f inverse is, the first thing is minus 7. Because the last thing that was done was plus 7, so the first thing we have to undo is plus 7. That means minus 7. And then we have to divide by 3, because the next step to undo is times 3. So to undo it, we do divided by 3. And let's check out if the g function is actually doing that. If you look at the g function, the first thing you would have to do here, if you took an x and plugged it in, you'd have to subtract 7. So that's the first thing in my list. And the next thing is to divide by 3. So that's the second thing in my list. Now compare the f inverse with the g inverse, with the g of x. Compare the f inverse with the g and see that the steps are the same, so that means g is the inverse of f. By the way, the order of the steps here in the list is the same as the order of operations, and the way you can tell that you're doing it in the right order is if you think about plugging a number in for x, what order would you have to do the calculations in? That's the order you want here. Alright, now since these are the same, we can tell that f and g are inverses. Okay, here's another one. Determine whether f and g are inverses when f of x is 3x minus 9 and g of x is x plus 3 over 9. Well, the steps for f of x are times 3 and minus 9. And so the steps for f inverse should be the opposite of minus 9, which is plus 9, and the opposite of times 3, which is divided by 3. And let's see if g is doing that. If we make a list of the steps for g of x, the first thing that happens is you add 3. So that's first in our list. And next in our list is going to be divided by 9. And so clearly we can see that this list is not the same as that list, so f and g could not possibly be inverses. And maybe sometimes this is less work for you than composing the two functions. So, just keep this open as an option. I think this can be less time consuming than doing a whole lot of composing. And I hope this has been helpful, and I'll see you on the next lesson.